Welcome back, generals, to another Let's Fix Generals to Zero to make the best game ever. Good, so last session we did something. Yeah. Corrected name. Okay, so we now want to look into parse variable. Okay, so the last thing we were stumbling upon was that the name to variable index is a multi-map, right? It's multi-map. Can we let me comment out this one and this one, and let me put here if I can't hold on. Inside the functions, parse function here. Inside here we also look for parse fun, parse. Didn't we look for I don't understand. Hold on. Name to function index. There we go. Here. There we go. Find function index for name and source file. What? I see. Find function index for name and source file. Yeah. Right here. So equal range. Yeah, equal range. Right. Equal range. Okay, so I think we are looking for this guy. Then we go here and we search for auto begin and variable index, equal range, symbol name. Yeah. And then we say if std distance begin end is larger than 1, then we put a breakpoint here. Yeah? There we go. Oh, what do we have now? Uh, huh. Huh. Well, that is an outrageous value. Type 36. It's 24, yeah. Okay, that's a huge size. There's a very huge size. Let's check watch functions. Where are we? Script engine init. Oh, it is a big function. Script engine init. Right. Yeah, that function is huge. So that function is larger than... Holy shit. Holy shit. That is insane. So script engine symbol. Copy that, yeah. Yeah, it looks long. Oh. Yeah, there it is. Okay. Okay, then it means we need so it is 65,000 bytes longer. How much is this? That's an insane size. Or is it not? Okay. 150 DC. 150 DC. 86,000 bytes. Boah. It's very large. Boah. Yeah. It's really large. But I remember, yeah, there's a lot of stuff in it. Okay. Well, in that case, in that case, we have to get this one back to 32. Yeah. 32, then we move this down here. And then we copy this and we move 32. F. Yeah. Okay, let's try that again. Right. Um. So this didn't hit? Hold on. Begin, end. Yeah. Why is this not found? S-cache dig map. That's we need to demangle this. Right. Yeah. I wonder if we should maybe we should have a mangled lookup as well. But we can't. No, we can't have a mangled lookup because I wonder if we should also store the mangled name in the maybe. Yeah. Okay, so but we need to demangle it then. Itanium demangle. Yeah. Okay. So take this Itanium demangle. I find this here a bit upsetting that on one hand some symbol names have 2 underscores in the beginning, and then others will have 1 underscore in the beginning, but they both refer to the same thing. I don't quite understand this, and I don't like it because it makes it way too complicated. Because we don't know what the expectation is. Why is it inconsistent? Maybe we should say maybe mangled name. Yeah. How about we create a is Itanium encoding? A valid Itanium encoding requires 1 to 4 leading underscores following with Z. How about we create a function static std string view normalize normalize Ethereum encoding. Const std string view mangled. By the way, why do we pass here a reference to string? Because of CSTR. Right. Mangled. Yeah. Okay, so here we say if strip let's say before we do this, let's ask ChatGPT a question. Is there any difference between? Is there any difference? Does the amount of leading underscores have any meaning in Ethereum mangled names? Does the amount of leading underscores have any meaning? There can be 1 to 4 underscores followed by a Z symbol. The number of leading underscores before Z is not semantically meaningful in itself. However, the number of underscores can vary depending on the compiler and platform. Single underscore, this is standard Ethereum name mangling prefix. Most C++ symbol begin with underscore Z. Double underscore, some compilers such as GCC may introduce an extra underscore in certain environments, such as when targeting certain platforms or using special linking. Okay. 3 or more underscores. This is uncommon, but sometimes extra underscores can be introduced by preprocessor macros, RBE variations of specific linker option. Practical meaning. In general, only Z is part of the official Ethereum mangle scheme. More than one underscore is usually an artifact of the toolchain rather than having inherent meaning to the mangling itself. If you see multiple underscore, it might be due to platform specific conventions. Yeah. Compiler generated name modifications, leading underscores for certain symbol visibility rules. Okay. Such as preprocessing macros, adding extra underscores. I guess it's good enough for me. My impression is that we can safely strip it down to 1 underscore. So we say we do this here. Pause. Let's move this comment here. Let me say find first not of that pause. So we say if pass is that, then else. So we return just mangled. So we say this plus that minus that. Mangled data, mangled size. There we go. I think that would do. I think so, yeah. Find first not of that. Pos must be larger 0. Pos smaller equal 4. Hold on. 1. Ah, right. It's finding the Z, right? Right. So normalize Itanium encoding. Ah, we should also say, hold on, and this. I think it should be larger than 1. So 2. Yeah, so 2 underscores, smaller 4, and then pos. So we are at Z, and then we go down 1. I think pos plus, no, pos minus 1. Let's say pos minus equal 1. Yeah. I think that will work. Yeah. Okay, let's try that. Parse function. So here we should say, let's see, normalize Itanium encoding. That symbol dot name. Let's see if that works correctly. Put a breakpoint here. Okay, so symbol name is 2 underscores, and it's still 2 underscores. Well, that didn't work well. Because, what's now? Right. So it's not just about. So it's not just about the Z, it's about all. Okay, how about we say it's first not of that. Normalize. Itanium encoding. Let's just say normalize encoding. Then we say let's try that. Okay. Okay, so now we have this symbol. And the corrected name now has 1 underscore. Okay, so this is passing now. Okay. Okay, let's see if that succeeds. Nope. So we need to really remove all underscores. Huh. Okay. Interesting. Okay, well, in that case, then we create a different kind of function. Then we say static remove leading underscore. Then we say assert mangled.size is larger than 1 and assert mangled 0 equals underscore. And then we return mangled. We just say name, symbol name. Symbol name. There we go. Sorry. And then we call it here, removing leading underscore. Here. Okay. I can put this right in here as well. There we go. Okay, then this should now go through without error. Okay. Good. Then next step. Let's get back to our parse variable. Okay, so interestingly, it never hits here, so we don't have any duplicate names, right? That's strange. We don't have any names at all. Because, right, it never we need to demangle it, right? So, variable name. Yeah. Good. Variable name. There we go. Good. This may hit now. Let's remove this breakpoint maybe. Okay, there we go. There we go. Get command availability key battle plan update. So there are so we have here begin and begin +1, which doesn't work for some reason. Why not? Begin ++ maybe? No. Why is begin +1 not working? So I cannot see the next item. Okay, but there are entries with duplicates. Here's another text ID, unknown image, key staff detector. Do they have other given index? M variables 0x712. There we go. And that gives variance 1 address. Okay, it does have an address. Yeah. Variable name. We have a symbol address here as well, right? So let me see. Value, and that value matches the one we see down there. Yeah, 98F668. Yeah. Okay, so it's this one here. 712. Okay, I think what we can do is, and we already did it for the other one here. There was a function here, find function index for name and source file. So we create also a function, create full array name, find. Where's this used? Here. How about we move this function down here? Find function. Find function, let's call it by name and source file. Yeah. Let's move this down here. Okay. And then let's create another function, index t, find variable by name and address. const std string variable name and UN64T address const. There we go. Okay. And then we take this guy and then we put that in here, and then we take name to variable index equal range variable name blah blah, and then variables dot yeah, variables variance remind me, why are there variants? Variable variance. Why are these added again? I forgot already. So we have multiple different symbols, but then we also have variants within the symbol. That's kind of confusing. Oh boy. Interesting. I will be right back. Yeah, so I think we should document this better. So variance, local static variables in file within functions, there can be duplicates. Right, within functions, there can be duplicates within functions. Variance. Right, okay, so we say variance in a single function can be multiples. In a function can be multiple with the same name. In functions can be multiple with the same name. Yeah, I hope that that helps. Let's add a dot here as well. Okay, let's go back to here. Okay, then we say variance. What is this? Variable variance. Ah, hold on, we have a find variance. Why don't we just call that? Yeah, find variance. If find variant address is not null pointer, if that dot find variant is not null pointer, then we return that. Yeah, that's it. Yeah, that looks good. And then we go here to our function here. So we have the variable name, Itanium demangle, we find it, and then we, okay, we don't need this anymore. Look at that. And then we say, hold on, we don't have an address. Oh, we do have an address. Yeah, so we give it a variable name, and let's put here uint64t address. How about we shorten this to name address symbol dot value. Can it be 0? I think not. Let's put an assert. Address is not 0. Address and find variable index t const index t variable index how about we call it var address, var name, var index, var name, var address. Okay, so it finds it eventually. Then we say if var index is not invalid index, then we have it. Then we go in here and then we can start doing assertions. Yeah. Okay, let's delete that. And let's what do we want to assert? We want to assert, let me see. First we want to get m variables var index, then variable, and then we say variable dot, probably want to have it, not const. What do we do in function? There we set the m type. I think we should do the same here. Set the m type, yeah, variable, n type, symbol, raw type, symbol, raw type, yeah. And then, oh, look at that. Here we go through all these. How about in a function? Hold on. CPP types, variance. Here we have functions for find variance. Why don't we have the same in function? That's a good question, isn't it? How about we add a function here, get find variance, and oh, that's a class. That's stupid. Where's the function? Here. There we go. Find variance. Function variance. There we go. By address, right? Yeah, by address. Function variance. We did a mistake. Function variant belongs there. Look at that. There and there. Okay. And then we say has context. No. How about we move it up here? There. Good. Then we take this guy, get source lines. What is this function doing here? Ah. Okay. Okay, then find variance. We have this here, we have it there. We go down here and we copy it here. We take function, put it there, and there, and there, and there. Variance and function. And just like that, everything should work. Find variant, yes. And then here we say, here function variant, variant equals find function dot find variant address. Yeah. And we can make it const. The question is, should it must return a result, right? Assert function variant is not null pointer. And then it should assert these guys. And then we can get rid of this guy. And so here, assert variable. Let's make these consts. You know what? Let's shorten the name to address as well, because we do it on the other one as well. Name. Variable index. Good. Assert. Let's do the same as we did here, which is this. Let's copy the whole thing. How about that? Okay, so we have variable variance. Call it variable variance. Variable. Find variant address. Assert. Yeah, that's a good question. Number of sections. What is in there in the variable variance? Nothing interesting. Nothing interesting. So maybe we should say symbol variable dot section m section equals this one. Yeah, let's try that. What else is there? Symbol. Let's comment this out. What else is there? M type. Variable name. We could also save the Mango name for what it's worth. I don't know if we really need it. Maybe not. Reference by source files. Type section, description. No, there's not much intel on this. So I think the assert on the section is maybe good enough here. Yeah. I mean, for here we assert the maggot name in the section. Why is the section? Ah, right. No, huh? Function variant. Ah, for like destructor and stuff, right? Yeah, I wonder. Let me see. This name that we this one here. This name. Copy value. And find 1, 2, 1, 2. Yeah, okay. So there are 2 and 2 different addresses. Yeah, okay. But the maggot name basically will be the same for these guys, right? So for function we have mango name. Function variant mango name is here. Yeah. Let me see. This one here. Open. Let me open this guy, but not with a demangling. So this one. Ah, it's already open. And then we search for this one. There we go. Aha. The name is different slightly. Look at that. Okay. Huh. So we could have like demangled name lookup with this, yeah. Okay, let's store that name as well. Let's store that name as well. Variable variant. This is function variant. Maggot name. Yeah, so we do the same here. Function variant, variable variant, maggot name. And then we do this and this, and then variable variant, this maggot name equals remove leading underscore. Symbol name. There we go. And we make it not const. Variable, not const, yeah. Yeah, I think that this will work. Okay, and then we remove all this. We stop debugging and variable and section. That variable variant. Yeah, I think this looks good. Okay, let's put a breakpoint here. All right, so variable, type, section, BSS, yeah. Variable variant, yeah. My good name, and well, let me see. So we'll remove one of the underscores, and now we can't see it anymore. For m variables, for m variants. There we go. Yeah. In theory, we could also now add this to a lookup table, but I think we don't need that. So yeah, doesn't matter. Good. Let's see if we hit an assert. And we do. With a count. Let's see, variable. Oh. Parse variable. Does it not return anything? Ah. I see. So we need to return true here. Yeah, let's this one is passed, right? Yeah. Okay, I think then we can remove this one. Okay, this looks very good to me. Yeah. All right. And retry. A66. Okay. So it has only found much less. So we need to look into that. Yeah, okay. How much is it? 593. Okay, so it found much less. Okay, we need to find why that is. Okay, I will take a short break now. It has been 1 hour. Yeah. And then we continue after. Good. I wish you a great day or night. Until next time. Goodbye.